All right, you guys. So the second part of Module 15 is we're going to actually do all of the math from the hypothesis writing that we did for section 15.1. Okay, so there's going to be two different ways we're going to do the testing. And the first way that we're going to do it, we're going to need to come back and get our numbers from this table. These are going to be based on our level of significance, which is alpha. Okay, and you should recognize this we use alpha when we're talking about the area under the tails, right? So if we're talking about right-tailed, we're talking about the numbers that would be above what our hypothesis is or greater than, right? If we're talking about left-tailed, we're talking about the numbers that would be less than negative the critical value. Okay, and the critical values are just the numbers in this table. And if it's two-tailed, we're talking about it's just not equal to, it's just different from our null hypothesis. So it's going to be, if we're using a critical value, both greater than or equal to and less than or equal to if we're going to the negative, if we're going to reject the alternate hypothesis. Okay, so here we go. Steps for the z-critical method, stating our hypothesis. I think these steps were on our last one too. We practiced really hard on stating our hypothesis on the last ones. Step 2, state the rejection rule. We'll get there. That's where you're going to use your critical value. At that bottom that you can still see on the screen that is highlighted green, that's going to be where we put the critical value, step 2, in the rejection rule. Step 3, here's the math, calculating the standard deviation. On the side over here, I was just thinking that what we're dealing with here are going to be normal curves, larger samples, and that's going to be the pink curve I have there is a normal curve. What we're going to be getting to in 50.1, like we had also done in chapter 14, is a t-value, which is that shorter, longer curve. So you can tell, because the data is more spread out in that shorter, longer curve, that our you're not going to have as good of data because it's more spread out, right? So right now, like in the real world, what's happening is you need more and more data to get things figured out with a greater reliability, which means more and more testing. And I just cannot believe how well what we're doing matches with what's happening in the real world right now. But you just need more data. We need more tests. We need everybody to be tested, or we need the antibodies tests. We need to see if we can get people out there. Because when you have less data, like not a normal curve, less than 30 for sure, you're just going to have more error. Okay. It's just going through the Z data. All right. So this is everything we just talked about last time. Sampling distribution of p hat, assuming that the proportion is equal to the proportion of the null hypothesis. And we're trying to figure out the difference between the hypothesis so that you can tell which one you should reject. Remember, it's not enough to prove one of them, but it should be enough to reject one of them. Okay, and stating our conclusion. Okay, the very last, and we'll go through that. This gives us like a sentence starter to do it. So if you are going to reject the first one, you would write it as there is enough evidence at the significant level of significance, alpha, that whatever that hypothesis is. And if you are not going to reject your null hypothesis, there is not enough evidence at a level of significance that blah, 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 whatever the second one says. It won't make as much sense until we actually do a couple from start to finish, okay? So this is the second way we're going to do things. Instead of using the critical value, we're going to use the p-value method. And that's looking more at the proportion of what's happening. And I just underlined some things here that, like the test statistic, the p-value is therefore a measure of the evidence against the null hypothesis. In the case of the test statistic, the larger it is in magnitude, the further the mean of the proportion is from the null hypothesis, the more evidence we have against it. Okay, they're farther apart. But when we're talking about the p-value, okay, because it's a proportion, the smaller it is, the more unlikely it is to happen, right? Like 1%, the proportion of 1% smaller than 10%, and 1% is definitely less likely to happen than 10%. So we're just looking at two different things. So instead of finding that kind of Z number from the table, we're just looking at, we are going to reject the null hypothesis if our p-value is less than or equal to just our alpha value. That's all we have to look at instead of going back into the table and using a specific number of significance. So this way is going to be a little bit more subjective. Okay. And it just goes through your pictures. Okay. Step. There's the 4 steps for the p-value method. Okay, they're the same 4 steps, really. This right here, instructions on how to do a z-test on the TI-83, TI-84. I've noticed, this is just some experience for me to you, the more I've been working at home and I don't have a printer, that I've been taking pictures of things I need to use right away, as opposed to having to go back onto my computer and find the right document and trying to look at it at the same time. So if you guys want, I'll just kind of keep talking for a second, trying to draw this out and give you time to take a picture of this if this is what you want. All right, moving on. All right, first example. The Center for Disease Control and Prevention reported in 2010 that 20% of Americans smoke tobacco. So that 20% is going to be our null hypothesis. That's what it's not a census, but this is the large number of data that we're looking at, right? That's the population is all Americans, right? A random sample of 400 Americans found 76 who smoked. So think of it as this. We are trying to test whether or not the Center for Disease Control has the correct proportion of Americans who smoke. So we took a sample of 400 Americans and found 76 who did smoke. So our null hypothesis proportion is 0.2. That's that 20%. Okay. But we are going to use p hat. If you look kind of towards the bottom of the screen, we found p hat, which was 76 divided by 400, to be 0.19. So we're trying to decide, do we think that that number that the Center for Disease Control and Prevention came up with is correct? And we're checking it by doing a sample of Americans, and our sample found 0.19. So the math that we are going to be using will give you a good way to say, yes, they were correct, or no, they were not correct, okay? And it wants us to see if it has changed using the critical value method and level of significance. So we will have to use the table. So when you go back up to the table, what you should find, if you look under alpha at 0.10, and I put it down, whoops, I'll highlight it in green down here, is that the Z number was 1.645. So since we are just trying to decide that it is not the same as 20%, we're not trying to say it's smaller than that, we're not trying to say it's bigger, we're going to do the two-tailed test. So that's why our rejection set is that our Z data is less than or equal to negative 1.645, or it is greater than or equal to positive 1.645. We stated our null hypothesis that the proportion is 0.2, and we're trying to say it is our alternate hypothesis or alternative hypothesis, it is not equal to 0.2. Okay, so step 3, calculate the standard deviation, the sample proportion, and the z data, and state the rejection rule. Okay, so what we did all of this because we wanted to find this z-score here. In order to find negative 0.5, we needed to find our p-hat, which was the proportion of the sample, and we needed to find our standard deviation. Okay, and it says up here what you're trying to use for that is the original 0.2. You're not using the 0.19. Okay, because remember, we're trying to find how far away our p-hat is from the original mean that they had, proportion that they were using. Okay, so you can do all of those. I'm going to pause this in just a second. Well, maybe I can get through the rest of this. You are going to use all of those numbers to find that negative 0.5 number. However, you could go back up and put the information into the calculator from the steps above, and you should also get negative 0.5. Double check yourselves. I'm going to pause this. Wish there was a shorter way. Okay. So we have two numbers we are looking at. We are looking at that negative and positive 1.645, and we are comparing it to our negative 0.5, and we are trying to decide if it is greater than or less than. So let me erase this here. I circled it. Is negative 0.5 less than or equal to negative 1.645? False. I sound like Dwight, right? False. Negative half is greater than negative 1.5, basically, right? And the second question is negative 0.5 greater than or equal to 1.645? Also false. So we do not reject the null hypothesis. There is not enough evidence at a significant level of 0.10 to show that the proportion of Americans who smokes have changed from 20%, right? It's basically the same. Okay, plus somebody could have been lying. It's kind of looked down upon to smoke. I mean, it should always be looked down upon to smoke, but it used to still be kind of cool, and I feel like that coolness factor has gone away. So the second example is we're going to use the P method, okay, which you can see I had to erase my number. I forgot we were doing that at first. We're going to use the P method to find it, which means we are just looking at our z-value or our p-value compared to our alpha. We don't need to find, there's no significant level. We don't need to look at that table and find another number, okay? The National Transportation Safety Board publishes statistics on the number of automobile crashes that people in various age groups have. You people aged 18 to 24, maybe they meant young people aged 18 to 24 have an accident rate of 12%. That's our null hypothesis, okay? A researcher claims that the population proportion of young drivers having accidents is greater than 12%. They're like, no. I know young people, they're getting into way more accidents. So we're looking at greater than 12%. That's our alternative hypothesis. So we're looking at the right-hand side, and we want it to be bigger. Her study examined 1,000 young drivers and found that 134 had an accident this year. Perform a hypothesis test using the p-value method with alpha is equal to 0.05. So our null hypothesis proportion is 0.12. We were given 1,000, a sample of 1,000, and 134 of those 1,000 were what? In an accident. Is that correct? That year, for that year. gosh, I had, from the time I was 16 to like 21, I had like an accident a year, I think. I wanted to show you that right away, the first thing I do is I find p hat, so 134 divided by 1,000, 0.134. Then you're going to find your standard deviation, use those numbers, both of those numbers you found, put it back in for your z value, and we get 1.36. Okay. I skipped step 2, I'm sorry. State the rejection rule. Reject the null hypothesis if the p-value is less than or equal to 0.05. So we're going to reject our original hypothesis, okay, if our p-value is less than or equal to 0.05. Okay. So stating the conclusion, we found our z data, 1.36. We use that here to find the p-value. Which is in the same place in your calculator that you found the z data. So when you go back through your calculator and you do stat, and it's in the notes from above, when you go into your calculator and you do stat, and then you right arrow over to tests, and then you arrow down to one prop z test. Okay, it will give you not only that z is 1.36, it will also give you that p is 0.0869. Okay, so the question is 0.05, which is our alpha, is our alpha number greater than or equal to the p-value? And it is not. So we do not reject the null hypothesis. There is not enough evidence at significance level 0.05 to show that the proportional of accidents in young drivers is more than 12%. Okay, so even though our sample statistic was more than 12%, this is just saying that that could just be an accident in the data, right? So it's close enough using this p-value method that it could just be an accident in the data. Okay, we'll do some practice problems with the homework next.